So welcome to the new video. Today we are going to solve a new question. Max consecutive ones 3. Given a binary array nums and an integer k, return the maximum number of consecutive ones in the array if you can flip at most k zeros. Means suppose you have an example like this. So we have to return the maximum number of consecutive ones. By seeing this array, what can you tell about the maximum consecutive ones? You can say here are 4 consecutive ones, here are 3 consecutive ones, but we can also flip at most k zeros. Suppose here k is 2, so we can flip at most 2 zeros. So now what is the maximum consecutive ones? We can flip, suppose we flip this 0 and this 0, so it becomes 6 consecutive ones. Suppose we can flip these 2 zeros, then also this sub array becomes maximum consecutive ones. So answer is 6. Here is the reason. Similarly, in this we can flip at most k 3 zeros. So I can flip this and this, or I can flip these 3 zeros. 1 2 3 4 5 6 7 8 9. Here it is 9. If I can flip these 3 zeros, then I can have 1 2 3 4 5 6 7 8 9 10 consecutive ones. So this is the answer. So now what is the naive solution of this? We can think this question like we can create subarrays. By using 2 for loops, we can create subarrays. Suppose this is a subarray, then this, then 1 1 is a subarray, then 1 1 1 is a subarray, then 1 1 1 0 is a subarray. Now we have to create a subarray with at most 2 zeros. So this is a subarray with 1 0. This is a subarray with 2 0. Now this subarray is not possible because we can't flip 3 zeros. We can only at most flip 2 zeros. So this can be a one subarray. We will stop at this and we'll break the loop and we'll start a new subarray from index this. This is a subarray, then this is then wait a minute, this is a subarray, then this is a subarray, and then this is a subarray, and this is a subarray, then this can't be a subarray, so this will be only the subarray, then we will break. So till now max length was of this subarray, which is 5. Similarly, we can calculate when you will reach here. This is a subarray with 2 zeros. Okay, for this, then this is a subarray. This will be the subarray with maximum max length. Because suppose I will start I keeping I here and j here and j also here. Then first of all this subarray, then this subarray next iteration, then this subarray next iteration, then this subarray, then this subarray, then this subarray. And when you come here, then number of zeros become 3, which is greater than k. So you will stop here, break the loop, and max length you will update to 6. So let's write the code of naive solution, which will, I think, go ahead the time constraint because 10 to the power 5 length. So it will be 10 to the power 10, which is greater than 1 second, which is 10 to the power 8. So because time complexity will be n square because 2 for loops are there. So let's start with max length equals to 0, a variable, and we'll start a for loop. Nums dot size I plus plus. Now we will take a number of 0 count here, with initialize it with 0. Now second for loop will start from here only, int j equals to I, and j will be h dot size j plus plus. Okay, so if you got 0, then you will increase the zeros count. Nums of j equals to 0, then you will increase the zeros count, zeros plus plus. If number of zeros greater than k, you will break the loop, and also you will calculate the max length less than 0. If number of zeros are less than equal to k, then what you will do, you will calculate the length equals to j minus y plus 1. Suppose j is here, so 0, 1, 2, 3, 4. 4 minus 0 equals to 4, but length is 5, so plus 1. Max length equals to max of max length comma len. Now suppose 0 becomes greater than k, then we have to break. Then we have to break the loop. Now this should return the answer max length. I have not put semicolon. Okay, let's run this. What I have done mistake is no nums, it is nums error. Little mistakes. Now what I have done, not wrote int here. Max len comma len. Int max len. All the typos. See, but time issue will be there. See, time exceeded. So we have to get an optimal solution. Now we will see the optimal solution of this. So what can be optimal solution? First of all, we have got consecutive subarray. So we will click in our mind that yeah, we can use 2-pointer or sliding window. So let's make our example diagram 1 1 0 0 0 1 1 1 1 0. Let's make 2-pointer and let's keep them at the first index, and we will keep the count of zeros also. Let's keep the count of 0 from initially 1, and we have given the condition at most k, and we have max length also. Max length will be r minus l plus 1. Now calculate this. Suppose left pointer is here, r pointer is here. Now we will, because this is 1, we will increase the r pointer always. Let's increase the r pointer. Now it becomes 1. We will increase the r pointer. It becomes, max length becomes 2. We will increase the r pointer. Because it is 0 and 0's count is 1 and it is less than k, so we can now increase this max length. Now also because it is 2 and it is greater than equal to k equals to 2 actually here in this example, and max length become 4. Similarly, when r increases again, now zeros becomes 3, which is greater than k. Now we cannot update the mesh length. Now we have to trim the zeros from the left so that our slide name window concept works. And also we do not want 3 zeros. We cannot take this window now. So we have to trim the zeros. We have to update the left pointer. Till where we have to increase the left pointer? Till the zeros becomes less than equal to k. So let's increase here. No updation, no updation, no updation. Here it becomes zeros becomes 2. Zeros becomes 2 because it is left pointer is here, and we will increase the left pointer then. Now the zeros are 2 in this window, so we can increase the R pointer. Now we can increase the R pointer. Increase. Mesh length is 4 only. Mesh length becomes 5 actually. Then mesh length becomes 6 here. First becomes 5, then it becomes 6 on this index. Now after this, again zeros are 3. Now again we will update the left pointer. We move ahead. Zeros becomes 2. And our pointer updates. It becomes out of bound. So mesh length came 6. 6 only. Okay. So we can now write the code. What is the code of it? Let's see. We initialize it with mesh length equals to 0. And we will initialize L and R pointer to 0. And also we will make a count of zeros also. Count of 0 equals to 0 initially. Now we will loop. Till where the loop will go? It will go till nums.size. Also, if 0 becomes greater than k, what we have to do? First of all, if there are 0, if nums of r equal to 0, we'll increase the zeros count. Increase the zero count plus. Then secondly, if suppose 0 becomes, if 0 becomes greater than k, if 0 becomes greater than k, then we have to update the left pointer. But before it, let's check if nums of L equal to 0, then decrease the zeros first. Decrease the 0. Also update the left pointer till it becomes less than equal to k. When it becomes less than equal to k, then this while loop breaks. Now you will check if zeros is less than equal to k. If it is there, then mesh length will be updated to what? Mesh length, comma r minus L plus 1. Got it? Now R pointer will always move. Now we can return our mesh length and we will run this solution. Compilation is issue because there is no zeros. This is 0 variable. What is it is saying? I will check side by side. Okay. Integer defined overflow. Mesh length 0. Mesh length equals to mesh length r minus L plus 1. R plus while 0 greater than k. If L equals to 0, 0 plus. What is going to happen? What's wrong? Wait a minute. It was in the initialization part. In a sheet, it is like this. Okay. Now run. Boom, it is submitted. So what is the time complexity of this code? Let's see. See, r is going from 0 to n minus 1. That means big of n. That means big of n. Also, till where the left pointer is going in this while loop. Suppose in this example, let's take example that 1 1 1 1 1 0 0 and k is up go 1. So left pointer will move from r will move from here to here. Suppose r is here. So where the left pointer go? Left pointer moves from, because now zeros becomes 2. So left pointer have to move. Left pointer will becomes will increase from here till here. Okay, so it is one time only, so maximum it will go till here on average. So this is the time complexity 2n, big of 2n, and space complexity is big of 1 only. We have not taken also this space is big of n only because it is given in the question only. Big of 1 is the space. We are not taking anything. We are not creating anything. So this is the answer. Now we'll approach to best solution, optimal solution. Let's do one change and we will reach to the optimal solution, because this is taking a while loop extra big of n. We only have to remove this. So what would be our approach? Let's start, and we'll keep this code only. We'll change one code only. So this will be a final code. Now if I will do dry run for you, what is happening here is, let's see. First of all, time complexity will become this, and now I will do dry run for you. What is happening? This will also change. Okay, so let's do dry run. Left is here, right is here. It is 1, right will increase, max line will increase, right will increase, max line will increase, right will increase, and max line also increases because it is less than equal to k. Also zeros are less than equal to k. Now at this point our max length is 5. Okay, now when you move ahead, zeros becomes 3. When zeros becomes 3, now we have to move our left pointer by 1. Why? Because zeros can't be 3, and max line you can't. Max line you will update only when zeros are less than equal to k. Max line will be updated then only. So zeros are 3, max line will not update, although the window size is 6. Now when zeros becomes greater than k, then you will increase the left pointer by 1. Okay, now window size is 5, zeros are still 3, but you will increase the right pointer always. Windows becomes 6 size, still zeros are 3, maximum will not update. Zeros are 3, so you will increase the left pointer by 1. Still not updation, no updation here. Our pointer increases, and again nums of left is not 0. Now when you increase this time, nums of length will be updated afterwards. First of all, our pointer will increase to windows like this. Still some zeros are 3. Now when nums of left you found 0, then it becomes 0. Now you can update the max line to 1 2 3 4 5 is still 5. When it came here, it becomes 6. This is the point how your code is working. Now again our pointer increases, zeros are 3, left pointer moves ahead, zeros becomes 2, still zeros are 6, so no updation of max length. And in next updation, our pointer moves ahead and your breaks, while loop breaks. So let's take our next case. Suppose this for calculating time complexity. Suppose initially R was here, then it moves ahead. Zeros becomes 2. When zeros becomes 2, we have to move the left pointer, because if condition will fail, if condition will be true, then you will move the left pointer by 1. You will move the left pointer by 1. Now you will see zeros are not less than okay, so you will move ahead. Now you move ahead, you break the while loop, so it runs only one time. There's no extra big of n. So this is the case. Hope you enjoyed the video. We will meet in the next question. Thank you.